Okay, so in naming ionic compounds, now we know how to handle the anions, the names and the formulas. We also have to learn a little bit more about the cations. And so there are two types, and I don't know that your book follows this convention anymore, but this is the way originally they actually organized everything. But there are two types of metal ions. I call them type 1 now and type 2. Type 1 metal ions are ones whose charge can be predicted solely based on where they are in the periodic table. There's not a lot of them. Okay, it's group 1A, it's group 2A, and then it's scandium, and then it's silver, aluminum, cadmium, and zinc, and some people will include gallium in there. So let me show you where that is on the periodic table. Okay, so here's the periodic table. And so what I said was group 1 and group 2. So in terms of groups and stuff, that would be this, right? Group 1 and group 2. And then I said scandium, which is here. And then I said aluminum, zinc, silver, and cadmium. And so it goes like this. Now I usually include all of these, although, excuse me, indium also can make some others apparently. But predominantly what you see for gallium and indium, the ones I'm aware of, are +3 ions. And so how do you know what the charge of the ion is based on where it is in the periodic table? And it's actually very straightforward. Uh, it's it's this. It's either 1, 2, 3, or 1, 2, and 3. Now, for the 11, 12, 13, you have to subtract 10. That's where I'm saying 1, 2, and 3. If you have the older style periodic table, it's group 1b, group 2b, and then group 3a. So hydrogen makes a +1 ion. Lithium makes a +1 ion. Beryllium makes a +2 ion. And then scandium and aluminum here and here, right? Those are +3, along with most of the time gallium and indium. Zinc is always +2 because it's in group 2, and silver is +1 because it's in group 1b. Okay, so group 1. So again, position on the periodic table allows me to predict what their charges will be. Okay, so where does that leave us, right? All those other elements, it depends on what anion they're with, what their charge will be most of the time. So, give you an example, right? Iron can be either 2 or 3 plus. So iron on the periodic table is here in the middle. So all the other elements, like iron or cobalt or nickel, this one is a 2 plus or 3. Sometimes you'll see it in Roman numerals, 3 plus, right? Those are the charges that iron can be. All of the elements, like the transitional elements, the intertransition elements, the lanthanides and the actinides, lead, for example, down here on the periodic table, these can all have more than one different charge. We call it the oxidation number. Can all have different oxidation numbers, charges, predominantly based on the chemistries that they've been through. Lead can be 2 or 4. Okay, so in the naming of type 1s, you don't tell people what the charge is. In the naming of type 2s, you tell them what the charge is because it could be one of many charges depending on the chemistries it's been through. All right, so a little quick summary, right? Metals that can form more than one type of cation, those are the type 2s. That's everything that's not type 1. Charge is in the name. Charge is part of the name. Now, for type 1 metal ions, because you can predict it based on where it is in the periodic table, charge is not part of the name. Now, there are also some other cations that are important to know. There's ammonium ion, which is ammonia actually with an extra hydrogen ion on it. So ammonium ion is NH4 plus. And then there's mercury 1. The reason it's called mercury 1 is this number is the charge of each mercury atom. So if you think about Hg2 2 plus, right? There's got to be 2 plus 1 mercury ions in order to make that Hg22 plus. It turns out they're bonded together and each one has a plus 1 charge. So now what we can do is practice writing some of the ion names, right? So for example, sodium ion, because it's in group 1, right? It's type 1, it's in group 1. We just say sodium ion. But for iron, which is not a group type 1, is a type 2, right? If it's iron 3 plus, you have to write that, or otherwise people don't know that's the charge of the ion. And this is going to be really important when you give a name of a compound and people want to write the formula from the charges, okay? So why don't you go ahead and answer the remaining, what the names of the ions are, or what the formula of the ions are. Okay, so those are the answers. So calcium would be calcium ion. Chromium 3 plus, right? Because it has a 3 plus, and because chromium, if you go onto our periodic table, chromium is here. It's not one of the type 1s. You have to give the charge of the ion in the name. So that becomes chromium 3 ion. Cadmium 2 plus is part of the group 1 type 1s, right, that have a fixed charge. And scandium is also one of the type 1s based on periodic position table. There's cadmium down here. Periodic position on the periodic table. Position on the periodic table. I'm not exactly sure what I said there. That's one of those moments. And there's scandium, right? This is one of the type 1 metal ions. Now, manganese, right, and vanadium, again, manganese is here, and vanadium is here. Those are not type 1s, right? And I know it says that here, but when you're practicing, right, because it doesn't fall into the type 1, you have to include the charge in the name, right? Again, if you just see the name, though, this is manganese 2, it's the formula and the charge, and vanadium 5, it's the formula and the charge of the ion. Oh, and again, I didn't say this, but I think I implied it. After every one of these, you have to write ion, because if you say sodium, that's sodium metal. If you say sodium ion, that has a plus 1 charge.